to solve this question, t squared minus 3t minus 1 multiplied by t squared minus 3t minus 6 equals to minus 6. And we are meant to find the value of t. It is observed that what many people will do is to multiply the whole of this expression by the whole of this expression. This is definitely making it so complex. In order to avoid the complexity, if we observe what we have in these parentheses, we have something in common, which is t squared minus 3t, and the same thing is also here, t squared minus 3t. These two are common. By saying that, the first thing we're gonna do, if we say let t squared minus 3t equals to m, that is to say t squared minus 3t is going to be represented by m, and at the same time here t squared minus 3t is going to be represented by m. Therefore, our question can be written as saying m minus 1, and at the same time m minus 6 equals to minus 6. The next thing is to expand these parentheses and see what we have. M multiplied by this m, we're going to have m squared, then the same m multiplied by this minus 6, that's going to give me minus 6m, then minus 1 multiplied by this m, we're going to have minus m, then minus 1 multiplied by minus 6, that's going to be plus 6. T equals to minus 6, minus 7m, minus 7m plus 6 equals to minus 6, because minus 6m minus m will give me minus 7m. Then the next thing I'm going to do is to bring this minus 6 in, that is to the left hand side. If I do, what am I going to have? That will be m squared minus 7m plus 6, then I have plus another 6 equals to 0. Adding these two together, that is 6 plus 6, that's going to be 12, then I have m squared minus 7m plus 12 equals to 0. Since what I'm having here, m squared minus 7m plus 12 equals to 0, that is a quadratic equation, so I'm going to factorize at this point. Since my coefficient here is 1, that is unity, so it's easy to factorize by saying having two parentheses like this, then this m squared is going to be split into m, then another m here. This t equals to 0. What am I going to do now is to find two numbers in which if I multiply them together, it's going to give me plus 12, that is plus 12. The same number, if I add them together, must give me minus 7, that is minus 7. So what are the two numbers? The two numbers are minus 3, then minus 4. The same thing, minus 3, then minus 4. So what are we saying? We are saying that if we multiply these two numbers together, it's going to give me plus 12. Is it true? Minus 3 multiplied by minus 4, of course, it's going to give me plus 12. Then if I add the two numbers together, must be able to give me minus 7, then minus 3, then plus minus 4, of course, it's going to give me minus 7. But this is actually what I need. Minus 3, then minus 4, which I'm going to write here. So I say minus 3 here, then minus 4 here. Therefore, from this point, if two things are multiplied together like this and the answer is 0, so what does it mean? It means each one of them is 0, which I don't know. So I'm going to say m minus 3 equals to 0, or I would rather say m minus 4 equals to 0. If that it is, it means that my m equals to 3. If I transfer my 3 to the right hand side, then my m equals to 4. At this point, this is not the final answer. If you can remember from the beginning, we've set t raised to the power of 2 minus 3t equals to m. So what are we saying? This same m is equal to t squared minus 3t. So in this position, I'm going to substitute for n. So what am I going to write? T squared minus 3t. That is replacing my m. Then this equal sign is still there. This 3 is still there. Doing the same thing here. T squared minus 3t equals to 4. Then I'm going to bring in my 3 to the left hand side, so I'm having t squared minus 3t. Then if I bring it in, I am having minus 3 equals to 0, and at the same time if I bring my 4 in, I have t squared minus 3t. Then this is, we have minus 4 equals to 0. At the end of the day, we have two quadratic equations here, one here, and this is the second one. We're going to press further to find the value of t. For this quadratic equation, I'm going to use quadratic formula to step this further. That is, the value of t is going to be minus b plus or minus square root of b squared minus 4ac everything over 2a. In this case, the value of my a is equal to 1, that is coefficient of t squared. Then the value of my b equals to minus 3, that is coefficient of t. Then the value of my c equals to minus 3 also, that is the constant there. Then substituting this into my formula, I'm going to have this minus written, then the value of b is minus 3 here, minus 3, it is minus 3 plus or minus, then the square root of b, and b is minus 3, so I have minus 3a all square minus 4a, and the value of a is 1, then c, the value of c is minus 3 also, everything over 2a, and my a is 1. Definitely here I have 3 because minus multiplied by another minus is going to give me plus, so plus of minus square root of minus 3 squared is going to be 9, then minus 4 multiplied by 1 multiplied by minus 3, that's going to be plus 12, everything over 2a, which is 2 times 1, and I have 2. So this can be further simplified by having 3 plus or minus square root of 21, because 9 plus 12, that's 21 over 2. Of course, I'm going to get 4 values for t. For the first one, t1 equals to 3 plus square root of 21 over 2, and the second one, which is t2, is equal to 3 minus square root of 21 over 2. For the second quadratic equation, I'm going to get 2 values for t because my t has square here. So this can be factorized directly without going through quadratic formula. So I'm going to say first parenthesis multiplied by the second, then equals to 0. So this t squared, I'm going to split it. One is going to be a t, and the second one is a t. Exactly the same thing I did earlier on. So I need two numbers. If I multiply them together, I must get minus 4. Then if I add them together, I must get minus 3. That is, by multiplication, I'm looking for minus 4. Then by addition, I'm looking for minus 3. So what are the two numbers? Minus 4, then 1. That is plus 1. Writing the same thing, minus 4, then plus 1. If I multiply this, minus 4 multiplied by plus 1, of course it's going to give me minus 4. But what if I had this? Minus 4 plus 1, of course it's going to give me minus 3. So it is clear that this is what I am looking for. Minus 4, then plus 1. Writing that here, I have minus 4, then I have plus 1 equals to 0. Exactly what this means in mathematics. When we have 0, by multiplying two things together, two variables, two expressions together, then we can say t minus 4 equals to 0, or we say t plus 1 equals to 0. So in the first case, t equals to 4, or t equals to minus 1. So we say t3, that is the third value of t is 4, then t4, the fourth value of t is minus 1. So it is the final answer. In case we need to verify this answer, we go back to the question and substitute the value that we've gotten for t. We can substitute for this whole number. We have 4, we have minus 1, having it replacing wherever t is here, and check if the left hand side is going to be equal to the right hand side. In order to verify this, if we go back to the whole number where t3 is equal to 4, then t4 is equal to minus 1. What we're going to do is just that we're going to insert 4 wherever t is and confirm if this left hand side is going to be equal to the right hand side. So I have t squared, or t is equal to 4, so I'm writing 4 squared minus 3 into 4, then minus 1, all in parentheses, then another one t squared, which is, since my t is 4 now, verify. I have 4 squared minus 3 into 4, then minus 6. So I want to check if this is going to be equal to minus 6. Of course, this is going to be 16, then minus 3 multiplied by 4, that's going to be minus 12, then minus 1 t inside its own parentheses, and the same thing here, 4 squared, that's going to be 16, minus 12 here, and minus 6, still confirming if this is going to be equal to minus 6 or not. So here I have 16 minus 12 minus 1, that's going to be minus 13 here. Then at the other side I have 16 here as it is, then minus 12 minus 6, that's going to be minus 18. Then is this still going to be equal to minus 6? So inside the first parenthesis, at the end of the day, 16 minus 13, that's going to give me 3. Then inside the second one, 16 minus 18, that's going to give me minus 2. Then is this minus 6? Of course, yes. 3 multiplied by minus 2, that's going to be minus 6, then which is also equal to minus 6. That shows that the value of t we've gotten is correct. I haven't tested for t equals to 4, so I want to check for t equals to minus 1. If that is correct also, what am I going to do? Wherever I can find t in the question, I'm going to replace it with minus 1. So t squared is going to be minus 1 squared, then minus 3, then into minus 1, then minus 1, all in parentheses, then the second part, t squared, which is minus 1 squared, then minus 3 into minus 1, then minus 6. Is it still going to be equal to minus 6? This has to be in its own parentheses as it is to have an accurate answer. So we're going to have 1 here, minus 1 in parentheses, then square. We're going to have 1, then minus 3 multiplied by 1, minus 1, that's going to be plus 3, then minus 1 is still there, then another one, we still have 1 here, minus 3 multiplied by minus 1, that's going to be plus 3, then minus 6 is still there. Is this going to be equal to minus 6? I'm still checking. In the first one, I'm going to have 1 is going to be cancelled by minus 1, so I have 3 in the parentheses here. Then in the second one, 1 plus 3, that's going to give me 4, then 4 minus 6, that's going to give me minus 2. So this is also equal to minus 6. So 3 multiplied by minus 2, that's going to be minus 6, which is also equal to minus 6. So that shows that this value of t is also correct. And if you can test for the value of t1 and the value of t2, put it down in the comment section and let me see if it is also correct. I'm going to read that and I'm going to appreciate that.